I welcome all of you for another lecture by Dr. Thamban, Director NCPOR. So, Nahush Kulkarni, our head MC Goa, is there in NCPOR. So, sorry, sir, actually for making you wait for
No problem, I
almost
understand.
half an hour. Yeah. So Nahush, it looks a bit odd to actually
so can I
welcome
start, sir?
a director in his own house. But Nahush, I request you to please welcome Thamban Saab by presenting a bouquet. And then I would request our Director General to kindly
Thank you so much. I didn't expect this to be brought to my office.
And now I request our Director General to kindly deliver a welcome address for this lecture.
Yeah. So good evening and namaskar to all of you. Respected Dr. Meloth Thamban, Director of NCPOR, my dear distinguished delegates from Minister of Earth Sciences, India Meteorological Department, NCPOR, and many other organizations, Professor Das, our former speaker, and distinguished participants from various research and academic institutes, ladies and gentlemen. At the outset, I express my deep gratitude on behalf of India Meteorological Department, on my personal behalf, to Dr. Meloth Thamban for agreeing to deliver this special lecture, a popular lecture on polar amplification and its impact on the tropics. As all of us know that weather is no boundary, and perhaps we all understood that long back, but specifically, the polar weather can also influence the monsoon here or the tropical behavior of the weather and climate. That is also a new phenomenon people are grasping in recent times. So this is our scientists and engineers from the Ministry of Earth Sciences who have ventured to this branch of the science. And credit goes to NCPOR and the scientist of today who is delivering the lecture on the polar amplification and its impact on the tropics. Dr. Thamban Meloth is an internationally known scientist. He has made seminal contributions towards the polar meteorology and the polar science. He has been the brain behind many initiatives taken by the NCPOR and Minister of Earth Sciences. But the most important thing what I want to say, that NCPOR and India Meteorological Department work together as and when it comes up about the polar meteorology, about the expeditions, about the joint exercise being carried out in Antarctica from the very beginning. The first team who visited Antarctica included the scientists from India Meteorological Department in 1982. There has been the specific role by India Meteorological Department by providing the observations around the clock and special observations like radio sun, radio wind observations, and the ozone observations, the ozone Sunday from a long time. If I remember correctly, we started ozone observations in the country in Kodaikanal in 1928 perhaps. But in 1982, we started ozone observations in Antarctica. We have moved ahead beyond Antarctica, and now Dr. Meloth is spearheading the Arctic policy and its implementation, the role of India in the Arctics. Not only that, there has been a concept of third pole, and all of us know that the Himalayas acts as a third pole, considering its size consider its role in cryosphere, consider its role in water balance or the water cycle. And we are all happy that NCPOR and IMD are working together to enhance and upgrade the observational systems towards carrying out the research with the able leadership of Dr. Meloth. Once again, on behalf of myself and India Meteorological Department, all the meteorological fraternity and oceanic fraternity, I congratulate Dr. Meloth and express our deep gratitude and welcome for this special lecture on polar amplifications and its impact on the tropics. Thank you very much.
Thank you so much, Dr. Mahapatra, and thank you once again for inviting me for your the great achievement of completing 150 years. It's not a small thing, actually. You know, we are just completing only 25 years in next month, next year, in fact. So, congratulations to you and your team of the entire India Meteorological Department fraternity and Ministry of Earth Sciences, all our sister organizations, because ever since Ministry of Earth Science has been created with IMD as a leading beacon of that. So I think there have been a very good interactions as well as exchanges of ideas and working together. There's been never a problem. I think that's something the great thing happened, I would say. So we all work together. And therefore, actually, I would like to place on record that great support we get from IMD, especially in Antarctica. As you rightly said, actually, from starting from the way back when we started Antarctic expedition to till now, IMD has not only been supporting our observations there, actually the Met observations, but also supporting with several leaders to Antarctic expeditions. So almost every year when we look forward to the DG IMD to help us with one leader who is ready to spend the 12 to 15 months in a year, more than a year, in fact. So that is something great. I would say that the relationship we have it. So thank you so much. I think if you are all like
before you proceed, we would like to have
right, sir.
a formal introduction of yourself. So I am requesting Dr. Anup Mishra to introduce the speaker.
Thank you very much, sir. And actually, we have two popular talks today. So second talk is by Dr. Thamban Meloth. And Dr. Meloth completed his PhD from National Institute of Oceanography. And he got degree from Goa University in 1999. And he started his career as an assistant professor at Kannur University and scientist at National Institute of Oceanography before joining NCPOR in 2002. His research primarily focuses on climate variability and its impact on polar ice sheets and glaciers. He has undertaken multiple scientific expeditions to challenging and remote areas of Antarctic, Arctic, Himalayas, and Southern Oceans. And Dr. Meloth had pioneering contribution to polar and cryosphere studies in India, and he was instrumental in establishing India's first state-of-art ice core laboratory at NCPOR. Dr. Meloth has been awarded many recognitions for his scientific contributions, like the prestigious National Geoscience Award by Government of India. He's a fellow of Indian Academy of Sciences, the National Academy of Sciences, and Norwegian Scientific Academy for Polar Research, NVP. He's also a member of various national and international committees and panels of World Meteorological Organization, World Climate Research Programs, Scientific Committee on Antarctic Research, and International Arctic Science Committee Council. Dr. Meloth has supervised 15 PhD students in various fields for polar sciences and has contributed more than 125 research papers in reputed international and national journals. Kindly join me in welcoming Dr. Meloth.
Thank you so much, Dr. Anup. Can I start with sharing my presentation now?
Yes.
Yeah, please.
Yes, please.
Right. Please share. Yeah, hope you are able to see the slides now in a proper mode.
Yes. I think you can minimize the
thank-
right side.
Oh.
minimize that top part you are saying?
No, this is our screen of the viewers. Screen of the viewers is,
No, you have to share the
yeah, now it is
only
fine.
the share screen. Okay, now is it okay now?
Yes.
Okay. So yeah, once again, thank you so much, Dr. Mahapatra, for that very great introduction and generous one. As I picked the topic for today, is that actually I thought actually as all of you are going through a climate change challenges at the moment. So I thought it's very apt for the meteorological as well as the climate scientist, in across the the country to also appreciate the kind of what is happening in the polar regions and how do they impact our lives on a day-to-day basis. So, as rightly pointed out, the National Center for Polar and Ocean Research under the Ministry of Earth Science is the nodal agency for the entire activities happening in Antarctica, Arctic, and even some of the activities in Himalayas. And I would like to again congratulate India Meteorological Department for this 150 years of service to the nation, I would say. So as we all understand actually that we live in a dynamic Earth, which is where actually the various spheres of the Earth system, like the atmosphere, the ocean, the land, and the cryosphere and the biosphere, each one of them are very complex and by themselves, and they also complexly interact with each other. The solar energy as the main energy source, and contributing to various processes on the atmosphere, from the cloud formations, the rains, and the atmospheric chemistry. How do they interact with these clouds, and how do they ultimately the cycling of the water cycling, the hydrosphere to the atmosphere, the various hydrological processes, and what happens to the cryosphere, like the glaciers sitting over the mountains, as well as the sea ice formed in the ocean, as well as the land ice sitting over in places like Antarctica. And each one of them have their own life, but they also have a very related life. So therefore we consider it's a very complex system. And as in the previous speaker was trying to point out, actually, as the land cover is changing, we also face various things which we have not seen in natural system in the past. So it's not only the natural things that contributing to those changes what we see, but we suddenly see this last few decades increased the interaction of the human being with the nature, and its encroachment to the nature and its interactions to the various other aspects. So I try to concentrate here on the cryosphere, as you have various experts sitting in atmosphere and other areas actually within the Ministry of Earth Sciences. So within the cryosphere we have two spheres. That is the Antarctic, which is a huge land sitting over in the southern polar region, which is nearly about the size of about 5 times Indian subcontinent. Covered with 98% of it's covered with ice as thick as 4.7 kilometers in some places, and on an average at least 2.5 kilometer thick ice is sitting over Antarctica. So Antarctica also has a history which is associated with India, which India and Antarctica were together about 200 million till about 200 million years back. Since then, India moved to the north and finally become a separate, by touching the Eurasian continent, colliding with it and forming the Himalayan mountain. Thereafter, changing our weather system, what we have, that is the monsoon systems. So the entire monsoon system also has to do with actually how well India is placed now and its separation from Antarctica. Therefore, I would say that we are siblings, and therefore we have a shared history in the past, and therefore it is important for us to understand them. And also, being a land which is of the huge size which I was talking about, acts as a giant mirror with entire, it's covered with ice actually, as a reflecting back most of the solar radiation which is receiving it. Then you have this Arctic, which is also a kind of mostly surrounded by land masses, except for small islands like Greenland and Svalbard. And most of the white spot which you see on Arctic is essentially the water which is frozen as the sea ice, we call it. So these are completely different in two different hemispheres, but have a very strong control on the climate of the rest of the world. Then you have this what they call actually as the third pole, which is essentially including the Himalayan glaciers and mountains, as well as the frozen land in the Tibetan region, what we call as the permafrost. So together they again make one of the largest areas of the frozen water other than the two poles. And each of them have their own implications on how the climate is changing and how they are responding to those climate change. Why do we study the polar regions? As we know, we are quite aware by now that actually the climate change is the grandest challenge that humanity faces now. And I will try to appreciate you in the coming several slides that the polar regions control most of the major global tipping points in this grand challenge which we face now. And the climate system is also modulating the global systems, including the tropics, because of being these two large giant mirrors sitting in the two poles, and the huge ice albedo effect, controlling the global atmospheric circulation systems. And they also happen to be the most vulnerable part on the planet Earth in a warming world, where the life is completely unique, and the life which able to sustain even in those extreme conditions. And having about nearly 70% of Earth's fresh water locked in its ice is something which is really something as we look forward in future, as the climate is changing. And this water can not only contribute to the increase in sea level, but also it can impact the way how the ice, atmosphere, ocean interacts with each other. Because such a increased amount of fresh water contribution to the surrounding ocean will create a layer of fresh water on surface of the ocean, which will have its own impact how the interactions do happen, and how do our current existing the oceanic circulation system is working. And as many of you would appreciate, that melting polar ice is the singular critical factor in sea level rise, because as we know that actually Antarctic has such a huge mass of ice sitting over there. If it melts entirely, it can contribute to about nearly 60 meters of its sea level change. And even if a small part of its, contribute to the sea level change, that itself is going to be, the planet going to be nearly unlivable. And also economically, these regions are so vital for our future, because they provide the living resources. As the population is growing and ever increasing the need for more and more better living conditions and better food, we start searching for those areas for food. And it's also, as it's warming, it's also becoming most of the oceanic resources are moving towards the polar regions. Therefore, in the future, I think those are the areas we should be looking forward. Places like Arctic is also have a very large amount of mineral resources. As the sea ice in Arctic is retreating, it opens up an opportunity for more hydrocarbon to be explored in the northern parts of those oceans, and several large resources of the placer deposits like gold, platinum, and various other mineral resources. Finally, they are also going to be very strategically and geopolitically important for not only our future strategic as well as security goals, but also potential opening of a new sea routes, like northern sea route, as the Arctic is melting and maybe become completely ice-free during 2040's summer or so. So these regions provide its own opportunities for a scientist as well as its own share of challenges. The opportunities include because polar regions are unique natural laboratories. They remain very remote and away from the people, spoiling it, and they also therefore are pristine. They happen to be an ideal place, therefore, to change the global change study, because they not only impact our climate, but also they respond to the changing climate in a very sensitive, because water is something which in the state, actually it's in such a state that any minor changes in the temperature, it immediately the ice starts responding to it, because its freezing point is just at 0 degree, So that's where actually that any changes happens, impact is much faster in polar regions. They also happen to be very ideal for studying the life in extreme conditions, because with all this extremity in those areas, the life is still thriving. It's not only just surviving, but they're thriving, especially in the lower level, the food chain, like microbes and viruses and various other small organisms and so on. And, all those things actually are thriving. So it is important to understand how do life survive in extreme conditions, and how do they manage to become, thrive. That will provide you our future, opportunities to understand the different other planets as we start exploring planets like Mars and so on. Finally, there's a huge opportunity for us to, as we know that the Indian monsoons becomes the finance minister as well as the every other minister you call it. And as any changes in monsoons will impact a large number, number of population, but also it's our economy. It will strain our entire planning for the coming, decades. So any contribution to understand those the linkages between poles and tropics will improve our the forecasting ability in future. In season wise as well as to intra-seasonal to intra-annual to decadal scale, which is going to be extremely important as we start planning it. However, there are many challenges to undertake studies in polar regions, because they are very logistically challenging and extremely expensive, because everything has to be taken from the mainland. So the expense is something actually is very, and the continuity is something which is extremely important to be continued. We have a very unpredictable weather out there, extremely narrow, windows of this weather openings, which ensure that actually you will not be able to undertake all your activities as you plan in a tropical region. Anytime weather changes, and the weather, the extremity also ensures that you are unable to do your full potential as you would normally like to. And they are very harsh and challenging. And most of the time, science in polar regions are decided by the logistics, because the logistics support system, only can tell you actually where you can undertake the research, kind of research you want to take it, and how large it could be, and so on. Finally, the remoteness makes it very complex, and which is something which we have seen actually the COVID pandemic. How do we even supply things to such places actually? How do we undertake, continue the research we take there? And as the current the war going on in Europe, we also find that actually such a global interest also makes it not only challenging, but also more expensive. So all supplies, everything has to be, the supply chain actually, is decided by the global things in those areas. So now I come to the main topic of my today's presentation, that what are these polar amplification and how do they impact our climate system? As many of you are already aware, I would say that this is the polar amplification is nothing but actually kind of phenomenon where poles are warming faster and stronger than other parts of the Earth. We will come back to those potential reasons for that. But as you look at the two, the two parts of the globe is sitting, there at the northern hemisphere, you can see that it's relatively, really highly, biased towards warming the rest of the world, and also in some parts of the southern hemisphere. So this is therefore actually that we have a much nearly 3 to 7 times warmer than rest of the world, which makes it completely challenging in coming years, because as these are in places where you have a large amount of ice sitting. This Arctic is the most singular most important area where this amplification is taking place. As you can see, since 1980s, there has been tremendous increase in the warming. If you look at the temperature anomaly, nearly some of them are rising by 4 degrees Celsius over the last 100 years. Even localized warming up to even 7 degrees Celsius, which makes this entire area like a huge oven sitting over there, which also is a place for the ice coverage. So the Arctic sea ice extent is therefore declining at a rate of nearly 13% for decade, and it is expected that by 2040 or even before, that itself Arctic could be open for the, without ice during the summertime, at least in some part of the area. And the island, the largest of the island, which is the Greenland sitting there, it's already melting in a very alarming rate, and it's losing ice mass. Ultimately, it will also impact the circulation which is going around in this part of the region, which governs the global ocean circulation, what we call as the North Atlantic deep water, also the Atlantic meridional overturning circulation. So if you look at the various causes of the polar amplification, one of the most important factor is the ice albedo feedback. Because as I was trying to impress upon you, the ice is a huge white body which reflects back everything, this solar radiation it gets, nearly more than 90% of it reflected back. But as the ice is melting slowly, it gets replaced by either seawater in case of Arctic, or in case of Antarctica, it could be land, resulting in a lower albedo, which is making it more and more black body, making more solar radiation being absorbed and than reflected. It makes a continuous chain, the feedback chain, which makes this actually ultimately that as more and more ice melts, it leads to more and more warming of the region, ultimately melting more ice, and you have this continuous chain. Then, of course, Arctic has also got a stable atmosphere, unlike our tropics. Like tropics, we have a fantastic atmospheric convection system, as well as the vertical, everything happens actually in the atmosphere get mixed very fast and quickly, compared to in the polar regions which lack such kind of convection, which got a very stable atmosphere. Therefore, it traps most of the heat, makes the surface skin temperature of this the regions where the ice is there sitting are become more rise faster than in tropics. Then you have this water vapor feedback, because as it's getting warmer, the ocean is will produce more more and more water vapor, and also the more and more warm moist air start moving from tropics towards the poles. It of course normally as it reaches the polar region, it start cooling and condenses, but ultimately releases huge amount of heat, like latent heat to the atmosphere, further increasing the cloud cover and the polar region and intensifying the warming. Finally, in the ocean, we also have possibility of weakening of the Atlantic meridional overturning circulation. As the MOC weakens, we have also have a possibility that the warm water, which is the Gulf Stream, which is part of the the circulation system, still start going to north. However, the heat gets trapped there because the overturning circulation is becoming weak, so it does not start sinking. So you have the possibility that actually heat can get trapped, so that in turn that finally the return of cold water to tropic get reduced and making the Arctic more retaining the heat. See, these are some of the causes. Of course, there are many other causes actually, and most of these the factors are intertwined. They're interlinked, subtly as well as largely, making the Arctic so much actually under the impact of this climate change, with a nearly 50% reduction of the sea ice over the last ever since the satellite era, when they start monitoring the entire Arctic sea ice happened, is nearly 50% from the 1979 itself. So, and more dramatically during summertime, of course, in Antarctic ice mass, especially in the Antarctic peninsula as well as the Western Antarctica. The Eastern Antarctica is still really holding because it got a huge ice mass, compared to Western Antarctica, which is actually mostly large areas of Western Antarctica is below the sea level, which is just covered with ice on top now at the moment, as ice shelves and so on. Even there actually you find there is a continuous mass of loss of ice mass, which is about nearly about 150 gigatons of ice per year, which is causing a global sea level rise about 0.4 millimeter per year, which means coming in another, say, to another 100 years, you will have almost 40 centimeter of sea level rising. You consider the increased impact of these storm surges and the other the high tide time and all this. The impact on the coastal states can be enormous. How do the polar warming impact us? Remote. Therefore, why should we be so much worried immediately? There are several things which, as you must have seen, come across of late. Many of the heat waves and cold waves have direct relation what's happening to the Arctic, We have this, the changing rain and snow patterns happening. Even you have rainfalls occurring in the polar regions now. Especially we directly observe that in the Svalbard where we have a station. And these are actually such kind of thing, rain and thing, which also releases large amount of heat. So ultimately that changes the global, the atmospheric circulation systems. You also have increased heat waves as the ice is melting in Arctic, and you have also the possibility of more droughts and more extreme winters happening in the tropical regions. And as the ice is melting, most of the glaciers sitting over the mountains and the ice caps start producing a large amount of more water at the moment. However, after some years, you may have no water left in those glaciers. So you will reach a peak point, what we call the peak water. After that, actually, a lot of our population living in those areas will not be having sufficient and clean water. And throwing this permafrost, which is the frozen land, will also endanger a lot of life, especially a lot of the constructions and building activities in permafrost are actually facing hazards. And many of these glaciers, as they melt, also produce, the lakes, as we have seen recently in Sikkim, when the glacial lake burst and endangering a lot of population as well as the infrastructure projects. Then, of course, you have this warming ocean happening, also leading to the many of the life, threatening many of the life which just lives on the very sensitive temperature and sea level conditions. So there are a lot of damages to the life in ocean, and retreat of fishes to places more colder and easier life. So therefore, many of the countries do faces problem with seafood. Of course, we have changes in plants life and so on. So the melting ice and global sea level rise is something very interconnected. As we all also aware, actually, the thermal expansion is one of the big, huge factor which increases the sea level currently. And add to that, actually, the meltwater which is added to that together makes the global sea level curve now. So as we go further into the future, we also find that if you look at IPCC 6, we have almost about sea level will rise by about 0.4 meter by 2100. That is many of our lifetimes of our young generation, of which almost thermal expansion in Antarctica will be contributing almost equal. And Antarctica and Greenland together will be much dominant than this thermal expansion. So what we see today is much only a tip of the iceberg. As we get into the another several decades, we will be facing much more the problem from these melting waters. However, you should also note this point: Antarctica dominates the uncertainties. That means it is least understood how much it will be able to contribute. It could be 0.4 meter, it could be also 1 meter. That is a huge economic as well as social impact. So it is very, very important for us to understand actually how much actually this Antarctic ice sitting there and how it could be responding to the changing climate. Because the ice is sitting over a land, and the land, and it's, as I was mentioning, it's about 4 to 5 kilometer thick ice. So such a huge pressure is also making the basal part of the ice melting. So the basal melt can also make the loss of glacier can be sudden. It is just like a greasing between the ice and the rock, and such greasing can actually make this the stability of the ice very questionable. So we do not know much about that. So therefore, it is extremely important that we should understand more this region. And more, which can you close that? Yeah, as you can also see that more importantly, the sea level rise is not linear. As many of you are quite aware that actually the coastal regions, especially in the tropics and mid-latitude, are going to be the most affected than the place where it is actually ice is melting. Due to multiple factors, of course, and including a factor that as the ice is melting, actually in those areas, actually there is also the isostatic rebound is happening over there. So we are the places like the India and this or islands and those places are going to be most impacted to what happens in polar regions. So it is all the more important for us to understand because we are the real stakeholders there. So if you look at the Antarctic, the Arctic sea ice has been melting over the several years. And, for a long time, people were thinking that actually Antarctic sea ice is actually growing. If you look at this particular map, you can see actually that the red color shows actually that increasing of the sea ice trend. It was the case till almost 2016. So people are saying, okay, you're talking about the warming, but look at the Antarctic sea ice, it's still growing. But suddenly one huge El Nino event actually ensured that actually that is no longer the truth. And thereafter, there's never looking back. And Antarctic sea ice is also melting, so, in going to a situation where it is going to be completely, much bigger than what it is gained over the several decades. Of course, there are, the studies at NCPR itself shows that there are several reasons for that, reduced ice growth suddenly. And we do not know whether there will be any possibility of this again growing back, because we are currently at a situation actually where it is almost in a very, very highly precarious situation. So there are many factors, as including the ocean warming is one of the reasons, and the warmer atmosphere is another reason, and even the record deepening and eastward shifting of some of the what I call the low systems around Antarctica is also one of the reason for it. And there have been a series of intense and explosive quasi-stationary, the cyclones, what we call as the bomb cyclones in the around Antarctica. All this made actually that what we see now. So the changes what we see in Antarctica looks quite alarming, which was the importance of sea ice in Antarctica is not just that actually they also they are related to climate, but also they support the ice shelves around Antarctica, because sea ice is something again provide some buttering to the ice shelves, and the ice shelves in turn provide buttering to the buttressing to the polar large ice sheets. So these are the uncertainties actually. When things go change in the sea ice, it could impact the safety of the ice shelves. In turn, it could impact the safety of the ice sheets of Antarctica. And very recently, just last week, we also came to know from this, Copernicus climate service that we just crossed 1.5 degrees Celsius, warming. So annual global temperature anomalies related to those pre-industrial thing is almost we just crossed in 2024. So 2024 is going to happen to be the warmest year. Probably we will be hearing that every year, or almost every year, coming from down. So this is something very, very important, because the kind of the studies clearly shows that global warming exceeding 1.5 degrees Celsius could trigger multiple climatic tipping points. Tipping points are those actually that beyond which actually that climate is unable to come back. There are many factors actually which will not be able to, like for example, the Greenland ice sheet for that matter. It's almost this 1.5 degree. It's going to be completely lost in coming several decades and so. And one of the very critical component of the Atlantic meridional water interpretation, that is the Labrador, the Irving Sea convection, this is almost the verge of collapse now. This collapse could ensure that actually the warm water which is reaching to the Arctic could finally get trapped here, making the region much more hotter than it normally would be. Then you have this West Antarctic ice sheet, which is again can happen in just in 1.5 degrees Celsius or less than 2 degrees Celsius change. It can also be lost. And there are many other things which can also, as the climate is warming. But these 3 points which I want to raise are actually because that's going to be happen as we see now, because we are expecting actually globally we'll cross 1.5 degree, although in coming years we will have this this immediate problem to deal with. Therefore, it's very important for us to understand these regions much in a better way and how they could be controlling our climate system. Because warming Arctic, for example, Arctic and Antarctic are basically supported by strong jet stream traps the cold air, making the system actually like a huge port where the inside is protected from the outside warming. And as the Arctic is, these are very normal circumstances. You have a strong jet stream, a strong polar vortex, making the whole freezing cold air in this area. But as the Arctic is warming faster than lower latitude, this polar vortex start moving around, allowing cold air to be lost to the tropical part and warm air from tropics and subtropics to reach the polar regions. So this is making highly difficult to understand actually how they will be responding in future. Another important factor, as the poles are warming, especially in case of Arctic, it is also greening. This polar warming is leading to greening. So you can see if you look at the entire polar circle region, the large area is getting more and more greener now than browner in the past. This again used basically on the satellite data. So greening of Arctic is going to be a challenge for the existing community there, because they are not used to the kind of life which is, they need to be adapted. And the entire place, as I said, actually they are basically permafrost, which is frozen land. They could be, start releasing large amount of gases like methane, endangering also the lot of construction activities which is existing there, because actually this is basically frozen land. As a water loss, actually they can impact the land. Antarctica, if you look at actually in the last couple of years, you must have heard in the newspaper actually that several atmospheric rivers are reaching Antarctica. And I would rather call it actually it's breaching the Antarctic wall, I would say, because there is a Antarctic polar vortex system, one of the strongest on the planet Earth, allowing actually what remains in Antarctica, what happens in Antarctica remains in Antarctica. But as you see that these atmospheric rivers, which are typically very long, about nearly more than 2,000 kilometer length sometimes, and about 500 kilometer width, which have this large amount of moisture as well as warm moisture being transported from the tropics and subtropics. If they reach Antarctica in one fine day, you can change within one day. You can change the temperature and the moisture conditions there. So atmospheric rivers in southern hemisphere are already shifting towards Antarctica due to the ozone depletion. And greenhouse gas emissions being produced. And due to this shift, more atmospheric rivers are expected to make landfall over Antarctica and reaching this polar vortex. For example, actually, if you look at actually what happened in 2022, just March 18th, a place in Antarctica, a station called Domsey, where at that particular, because it's the end of March, it's almost you are on the winter, and within one day, the temperature rise nearly by 39 degrees Celsius within one day. You're talking about from minus, about at that time around minus 50 or something, it become about minus 11 or something. So all such kind of huge changes are happening in many parts. Like one of my PhD student also shows that actually many of these atmospheric rivers are the reason for the extreme precipitations happening there in Antarctica, especially coastline inland Antarctica, and they could be also have impact on the stability of Antarctic ice shelves. Antarctic ice shelves, as many of you may not be aware, they are basically floating body of ice, which is basically happened because the ice sheet is moving to the ocean. As I start moving, actually it's kept, finally start floating in the ocean. And they are very vulnerable, not only that actually atmospheric warming actually, but also the ocean is also warming. So any change in this kind of sudden, climatic events, it can impact this stability of ice shelf. In fact, one study clearly shows that about 60% of ice calving events in Antarctic Peninsula during this particular last 20 years were triggered by atmospheric rivers. So atmospheric rivers can act as a triggering mechanism. Of course, there are many other factors. So under future warming projections, an increased frequency of atmospheric river events could increase the ice shelf disintegration. So this is something which, again, one of the reasons why we say that Antarctic contribution to sea level highly uncertain. There are so many such factors which, if it happens, it can be completely, scenario could be completely different. So therefore, what happens in the polar region does not stay there, and it is start impacting us more than ever. So there are linkages between the poles and tropics. the main topic which I wanted to talk to this community. Because although there appears to be so remote for us people sitting in tropics, several studies have now shown that climate changes in the tropics and polar regions are interconnected. And some studies even demonstrate that actually substantial part of the Arctic warming itself may be driven remotely from tropics and vice versa. And the Arctic or even Antarctic sea ice flows could lead to increased tropical sea surface temperature, increased precipitation in the tropics, and a shift in the position of the ITCZ, and so on. So there could be many factors that we need to be studying more to understand how those changes can impact us. As climate scientists, many of you all are aware that actually the polar and tropical connections have been discussed even in the past. There are people discuss about the possibility of these atmospheric bridges and oceanic tunnels, and many of the teleconnections in the atmosphere can happen even within a very short period, within a season or in an inter-annual basis. But in the ocean, it can take a few decades. But as as we get closer to this, the scenario where the climate changes become reality, all this can be in the ocean also can become faster and faster. Way back in even 2000, nearly 20 years back, B.N. Goswami has already shown that there is a clear physical mechanism existing in the North Atlantic sea surface temperature influencing the Indian summer monsoon, especially through the Atlantic Meridian, the Atlantic, this anomalies which are existing directly, multi-decadal oscillation anomaly which is existing. So it has shown to be a clear direct impact through the atmospheric bridge system. And there are also more and more studies show that there are teleconnections existing between the monsoon and Arctic. However, you should also remember that this is a two-way street. What happens in the tropics can impact what happens in Arctic, and what happens in the polar regions can impact what happens in tropics. The primary mode of the transfer is basically the planetary waves, which is the atmospheric rosary waves in this case, which are essentially guided by the prevailing jet streams, and so therefore it start moving to a region actually which we normally don't imagine. Like for example, enhanced Indian summer monsoon can initially generate an upper level anomalous high towards its northwest and to the West Central Asia, and then start exciting downstream cells along the wave guide and ultimately reaching to the polar regions. And even if due to some reason the jet stream over the North Atlantic get affected, it can excite the Eurasian wave train and can affect the upper atmospheric monsoon circulation. Eventually, the kind of rainfall we can get, especially the extreme rainfall, you can get it. This was a classic paper which Krishnamurthy et al. Actually has pointed out wherein he was said that actually the South Asian summer monsoon has experienced increased rainfall over northwest India and Pakistan, and also seems to have contributed to the more intense local anticyclonic outflows from this region to further into the northern hemisphere, especially the Canadian Arctic and so on. So a huge amount of heat is getting transferred in that way, can get released to the atmosphere due to these extreme events, and they can ultimately cause very rapid sea ice melting in that regions. So basically, this poleward and eastward moving planetary waves can ultimately make what happens even in the Indian monsoon can reach those areas. And of course, there have been several studies showing actually that Arctic can be impacting monsoons on an interannual to subseasonal to decadal scale. And there are many studies showing actually that some of them can be due to a dynamic effect. Like for example, upper level divergence over monsoon region can kindly affect the surface convergence and so on. Then there is this very famous thermal effect, which is a mechanism which is already discussed in the past, where you have a tropospheric thermal gradient between Eurasia and Indian Ocean region can affect the strength of the monsoon circulation and so on. So this is one case actually where actually the publication shows actually that the influence of Arctic impact on the mid latitudes. As you know that mid latitudes get affected, it can also impact the monsoon system because we have a lot of connection to the Eurasian region. This is one of the publications from NCPR, which my colleague Saurabh Chatterjee group actually has shown that there seems to be a relationship between Arctic sea ice loss and a late season Indian summer monsoon rainfall. where they found actually increased extreme rainfall events in the central India seems to be coinciding exactly with episodes of the reduced sea ice in the Barents and Kara Sea in the Arctic. And they found that actually potentially a Eurasian wave train pattern is strengthening the Asian high and induce an upper atmospheric divergence over north central India, which ultimately can control the surface circulation, which responds to that upper level divergence by enhancing the convergence at the lower level. However, what is most important at this case also that it is important that actually sea ice loss alone cannot bring that. You should also have a warmer and moisture available actually in the Indian Ocean, which is happening currently. You should have a warm Arabian Sea to support this thing to happen, which is already the case, which we are seeing in many times. Even if you look at geological time scales, one of my colleague actually, Dr. Manish Tiwari and his team, actually Vikas Kumar and team shows that even if you look at the last 1,000 years, it also shows that actually a warm Arctic seems to be matching with a higher Indian summer monsoon rainfall. Even using different machine learning models also, they clearly say that actually that the surface temperature is the most important contributor to the increased monsoon precipitation. And there are, they also talk about the modulation of meridional thermal gradients over the Indian monsoon, basically facilitating the observed these kind of changes. You go further back in time, which is I'm talking about nearly 3 million years ago, which we call actually the mid-Pliocene warm period, which is an extremely important time period for a geologist because that was a time when we call actually some modern analog, when the atmospheric carbon dioxide was of something of similar as what we see today. Therefore, there were a lot of studies which are during that time period. So one of the study which our colleagues show that actually that very low Arctic sea ice extent can lead to stronger Indian monsoon. That means it is valid in the current times, possibly on a decadal time scales, on the millennial time scales, as well as even millions of years. So it seems to be very consistent actually this relationship. So the lower Arctic sea ice can lead to stronger South Asian monsoon during the probably in the coming decades. There's another study which from again our institute which shows that there is another relationship to the warmer Arctic. They show that actually there's an intensification of Arabian Sea cyclones, cyclone genesis potential actually, which seems to be connected to the warmer Arctic. My colleague Dr. Vidya and team actually shows that actually there's the increased post-monsoon cyclone, especially which is happening during the last more than 20 years, seems to be concurrent with a positive phase of the warm Arctic cold Eurasia feature, which probably is going to be again becoming a feature actually as we keep seeing this increasing cyclones in Arabian Sea. So this was that particular study which showed that actually the upper atmosphere circulation associated with this particular warm Arctic and the cold Eurasia kind of a positive phase induces meridional gradient in the subtropical jet, which ultimately helps in intensification of anticyclonic circulation over India and reduce the vertical wind shear, which is favoring the intensified cyclones over Arabian Sea. So this is something which we have been actually, consistent. I would say actually that there seems to be a very connectivity between what is happening in the polar regions does not stay there. It impacts all our climate and all our lives. As we are aware that currently the tropical oceans control most of the intraannual variance, what you see in the Indian Ocean intensity. But this could change because in near future, as the polar amplification, as you can see, actually poles are getting more and more warmer. This polar amplification can intensify its relative dominance in the Indian monsoon variability can even happen on a shorter time scales. Therefore, a warmer Arctic coupled with a diminished sea ice extent may intensify the Indian monsoon in near term. This is a kind of a talking point, I would say, actually, for a food for thought for many of you climate scientists. So I would say that the global warming is impacting the polar regions several orders higher than the rest of the world. And poles are deeply connected to our climate system, our sea level, of course, and the life systems and the food security, I would say. Therefore, requiring us to understand in detail for future predictability. Although these regions appears to be so remote for us, the climate changes in tropics and polar regions are highly interconnected. and more observations and integrating with the hierarchy of models and the both climate models and cryospheric models will be helping us to understand assess the climate cryosphere changes in a changing climate system. So therefore, I will invite you to, when you all visit Goa, actually to visit NCPR, which is the Indian gateway to the polar regions. It's in a beautiful coast. As we have seen that actually we sit in Goa, but we also have stations in Antarctica, 2 of them, and activities happening in Southern Ocean. And there's a station there in Arctic in Svalbard, and various activities happening in the Arctic Ocean, Canadian Arctic. And also our members have been to the North Pole as well as South Pole, providing us actually complete a global picture. Actually, what happens in those areas will be important for our future. I also want to congratulate and thank the India Meteorological Department on this occasion, because as we complete the 150 years, IMD has been a sustained presence in Antarctica, supporting from very first expeditions to all of the manning our stations, our observatories, as well as providing leadership to many of the teams. So thank you so much once again for that. So as I was mentioning, actually that we are in India in Antarctica. It's already in 1981. Currently we have 2 stations, both are wintering stations. We also have a presence in the Arctic since 2007, and we also have a station there, as I mentioned. And I say that thank you so much for your time, as well as I welcome you to NCPR, as well as undertaken various polar research activities, which will ultimately be important for you all to understand the Indian climate system or the monsoons. Thank you so much. Thank you once again for inviting me. You can unshare it here.
Thank you, sir, for a very insightful talk. And we can take up few questions. We have very scarce observation of cryospheric variables particularly in Himalayan region. So even the basic snowfall measurements are not available at many places, and even if available, then those are not in public domain yet. We can understand that this cryosphere is mostly in a sensitive region, and many institutions do not share these observations here. So do we have any plan for expanding our network for cryospheric variable measurements in Himalayan region?
Yeah, so I did not get into more details of that one today, because basically I thought I will focus more on the 2 poles. So as you may be aware that actually we have a station in Himalaya, especially in Lahore Spiti. We also have a network of automatic weather stations in that particular basin. So we are currently restricted to the Chandra Basin, because that itself is about a large area of almost about several hundreds of square kilometer area. And we monitor glaciers, we monitor the atmosphere, all the hydrometeorological parameters, as well as the water budget of the river systems, and so on. So I would say actually that because actually we are currently we are a small institution, but we can't completely do it alone. So therefore we have been looking for partners, including in the northeast and in the northwest. So we are currently collaborating with some of the institutions. I would also request IMD to focus on more on the modern meteorology, because I think ultimately you will not be able to make a lot of the predictions properly in the northwest India unless if you don't have a proper observation system. So in presence of DG, I would like to request actually to join our efforts. We are ready to share the data. I'm clearly saying actually the kind of data which we have we have got only 5 automatic weather stations. They have been providing data since 2014 for us actually, and they've been continuous data. In fact, one station even get almost live, real time. It's not a real time. So it is possible to set up systems. We have proven that, and they work very well without any interruption. So I would request actually IMD to join this, strengthen your modern meteorology, I would say. Thank you so much.
And one more information I can give regarding NCPOR, that WMO is establishing ANTARCC, Antarctic Regional Climate Center, and NCPOR will be the nodal office for that RCC. Already we have two RCCs in India. One is the South Asia Regional Climate Center at Pune, and recently the demonstration phase of Third Pole Regional Climate Center has been started. So IMD is again part of that Third Pole RCC, and the third RCC which India will be the part is the ANTARCC, Antarctic Regional Climate Center. So for that NCPOR will be the nodal office. So any more question? Anup, you can check.
Yeah, thank you. Yeah, thank you so much actually for that comment. Actually, I would say that yeah, I'm grateful actually that you all thinking that actually NCPR should be able to take leadership. I would say that actually it should be a collective effort, because Antarctic RCC is not going to be a regular RCC like what you see in the Third Pole, or even for that your other RCCs, because nobody really it doesn't belong to anyone. So currently we have only few gateway countries actually to Antarctica, which has promised to become the nodal agency. It's like going to be a hub and spoke system, unlike the normal RCC systems. So even within India, I would say actually that NCPR actually should be joined by NCWRF and IMD. Then only it will make actually, because we require the right modelers, we require the right people, observation people, and so on. Yeah, thank you so much.
Online participants are requested to ask their question if they have. If none, then I would request them to switch on their camera. We can have a picture together.
So
yeah, many of the cameras, what you see, the people are here. Actually, I think I'm showing the entire our people who are sitting in my conference room. So many of those people you can see there in the connected online are sitting here.
thank you, sir, for very insightful talk, and I would request Nahush to please felicitate Dr. Thamban Meloth by presenting a shawl and memento from India Meteorological Department. And I'm sorry, sir, the DGM had to leave for Patna right now, so he's not right now there
No problem.
in the
I've
office.
been sitting all afternoon. I understand that. Yeah.
Thank you, sir.
Right. Thank you
I
so much.
express
Thank you. Thanks to
our
all.
gratitude to Director NCPUR
Thank you.
for kindly sparing the time for us and delivering this lecture.
Thank
Thank you,
you.
sir.
Yeah. Thanks to all of my colleagues.